Okay, here are some factoring examples. These might be special patterns, they might not be special patterns, so we need to see if we can get these factored. Okay, my first one. I've got three terms. It doesn't look like it's going to be the perfect square, so I want to try to regular factor it. And I notice they're all even, so I'm going to go ahead and divide everything by 2 and put that 2 out in front to make my numbers a little bit smaller. So I'll have 2x squared plus 3x minus 5. Now you might be looking at this going, you know what, we haven't done one with a number in front here yet. That's okay, we're going to deal with that. So now, instead of just having x and x, I've got to also consider what can I multiply together to get this 2 I have right here. Well, that would only be a 2 and a 1. So instead of just x and x, we're going to have 2x and 1x. Everything else still kind of follows the same type of pattern. I look at this back sign, and it tells me that the signs don't match. So I'm going to guess that the plus goes with the 2 and the minus goes with the 1. This might not work. I might end up having to switch them later, but right now I don't know which way they go. Then I look at my 5, and my factors of 5 are only 1 and 5. So I'm going to guess again where I have to put the 1 and where I have to put the 5. It may or may not work. If it doesn't work, then we go back and we rearrange and we try some stuff. So when I FOIL this out, I'm going to have 2x squared minus 10x plus x minus 5. Simplify that and I get 2x squared minus 9x minus 5. And if I just compare that to this equation right here, I can see I'm not right. So that one didn't work. What I'm going to do is I'm going to flip-flop my 1 and my 5 around. So I'm going to have 2x plus 5 and the 1x minus 1. I'm going to FOIL them again to check to see if this way works. So I'll have 2x squared minus 2x plus 5x minus 5. Combine those like terms. And I had 2x squared plus 3x minus 5, which we got it. Matches this part perfectly. Now the reason it doesn't match my top equation is because I didn't distribute that 2 back in yet. So if I distributed that 2 back in, I would have 4x squared plus 6x minus 10, which would match my original equation. So factored, we've got it right here. First try didn't work out, so we had to flip-flop our 1 and our 5, and we got it on our second try. Okay, this next one. It doesn't look like it follows a special pattern because there's 3 terms, but 10's not perfect, the 3's not perfect. So I'm going to go ahead and try to factor it just regular. I can't divide the 3 and the 17 and the 10 by anything, so I'm going to start out with my 2 sets of parentheses. And I have to ask myself, what can I multiply together to get 3w squared? Well, that would be a 3w and a 1w. The sign on the back here tells me that they match, and this one tells me they match as minuses. So I'm going to have minus and minus. Now my factors of 10 are 1 and 10, 2 and 5. Okay, you might be looking at this saying, you know what, neither of those will get me to a 17. Well, we can't do that anymore because of the 3 out front here. And when you do the FOIL process, the outside term for this particular one is going to be multiplied by 3. So it's not just as simple as looking at the numbers anymore. So we have to guess which one to try. I'm going to go ahead and try the 2 and the 5. So I'm going to put the 5 here, the 2 there, and I'm going to multiply them, FOIL them out to see if it worked out or not. So we're going to have 3w squared minus 6w minus 5w plus 10. Well, I can see it's not going to work already because minus 6 minus 5 isn't 17, it's 11. So that one didn't work. So I have to try again. So I'm going to do a 3w and a 1w, and this time I'm going to flip-flop the 5 and the 2 around to see if that helps. So I'm going to do minus 2 and minus 5. FOIL it out, and I'm going to have 3w squared minus 15w minus 2w plus 10, and it looks like we got it. 3w squared minus 17w plus 10 matches identically, So we've got it factored right here. Okay, see what you think about these two. So kind of look at them, and hopefully you're noticing that this only has two terms. 4 is perfect, 25 is perfect. So it's probably going to be that shortcut. We have the minus sign, so we can be pretty sure it is that shortcut. Rewrite them first. Ask yourself, what can I square to get 4? And what can I square to get m squared? Then, what can I square to get 25? So I've got it written out as a squared minus b squared. I can go ahead and go right to my shortcut, which says a squared plus, or a plus b times a minus b. Okay, the second one. You've got to decide, does it fit that pattern or not? Well, it's got two terms. The 49r squared is perfect. The 9 is perfect. We have a minus sign, so it is going to work out for us. I can square 7 to get 49. I square r to get r squared. And I square my 3 to get 9. So when I use my pattern for this, I'm going to have 7r plus 3 times 7r minus 3. And I've got that one factored out. So with those two, I was able to use a shortcut. Okay, we better do the first one together here. This first one only has two terms, but it doesn't look like it's going to fit our shortcut, because 20 is not perfect and 5 is not perfect. But remember, the first thing I always want to check is, can I pull out a common term? And for this one, I can divide both of them by 5. And when I do that, it changes how it looks a little bit. So I'm going to be left with x squared minus 4. Now, if you look at this inside, it has turned itself into being perfect. So I can rewrite it as a squared minus b squared. So ask yourself, what can you square to get x squared? And that would be x. What can you square to get 4? And that would be 2. So when I factor this, it's going to be x minus 2 and x plus 2. Let me rewrite that for you. There we go. Okay, this next one. It's not the difference of two squares because there's three terms. Is it a perfect square trinomial shortcut? It doesn't look like it right now. The 9 is perfect, but 6 isn't perfect. So we want to try to factor it regularly. One thing I've noticed is I can divide all of these by 3. So I'm going to pull a 3 out, and I'm going to be left with 2x squared plus 5x plus 3. And now I want to check again to see if it fit that pattern of the perfect square trinomial, which it doesn't, because the 2 is not perfect and the 3 is not perfect either. So I'm going to go ahead and try to regular factor it. I start out with my 2x squared, so ask yourself, what can you multiply together to get 2x squared? Well, that would be a 2x and a 1x. Then come and look at your symbol. The plus sign means they match. This one means they match as pluses, so I'm going to have plus and plus. And now the nice thing is that my only factors of 3 are 1 and 3. So I know I either have to have the 1 first and the 3 second, or my only other option would be to flip the 3 and the 1 around. So let's try this one out first. Foil that out, and I'm going to have 2x squared plus 6x plus 1x plus 3. Not going to happen. I ended up with 2x squared plus 7x plus 3. And if you look at right here, I needed a 5x in that middle spot. So that one didn't work out. Let's check if it'll work if we flip our 3 and our 1 around. So I need to check this. Foil that one out, and I get 2x squared plus 2x plus 3x plus 3. Combine my like terms, and I get 2x squared plus 5x plus 3. Looks like it's going to work this time because we've gotten this inside part. Now if I distribute the 3, I'm going to have 6x squared plus 15x plus 9, and it does match. So when it's factored, it's 3 times 2x plus 3 times x plus 1.